Good afternoon, everybody. I'm Bill Ferrigno from the Developers Forum of the Home Builders and Remodelers Association of Connecticut. Welcome to our March Developers Forum meeting in webinar format. With us today are two guys that are going to introduce us to a lot about energy. Well, one about energy and one about getting energy companies going, I guess. So it's a very interesting topic. I think interesting and very timely for where we are right now with some of the volatility of energy markets. I think is getting everybody's attention right now. So without further ado, I'm going to introduce to you Greg Flynn, who is director of, where am I here?
Upward Labs.
Move upward. I'm sorry. Yeah, I'm sorry. I'm totally disorganized. Sorry. So Greg, you're going to tell us about what you guys do. You're kind of a startup accelerator. You're located in Hartford. You've got a small staff, but you're doing some important work, and it involves Daniel, which you're going to tell us about. So I'm going to go ahead and introduce you and turn the meeting over to you right now.
All right, fantastic. Well, Bill, thanks so much for having me. Appreciate it. And Jim as well. Thanks so much for the invite to present. So I'm going to spend 5 or 10 minutes just describing Upward Labs for everyone there, for those of you who are not familiar with us. And then I will turn it over to the star of the show, which is Daniel, so he can walk through his very interesting company, Wondrwall. I'm hoping everyone can see my screen now, but let me give you a quick overview on Upward Labs and what we do for those of you who don't know us. So we are a startup accelerator. We are located right in downtown Hartford on 20th Street. And essentially what we do is we recruit startups from all over the world to come into Hartford, to come into the state of Connecticut, grow their business, incubate their business, and connect with local companies who might be interested in purchasing or piloting their solutions. We do this in real estate technology principally. We also have an area of our business which is focused on healthcare technology, but real estate technology is really the core focus for our business. We do this for a few different reasons. One, to help our startups grow and succeed. Two is to help our partners find the latest and greatest technology. And we'll talk about Wondrwall in a second, which is a good example of the latest and greatest technology. And then thirdly, we do this because it's good for economic development in our region, good for economic development in Hartford and for the state of Connecticut. We've been around roughly 3 years now. We've invested in over 33 startups as part of our program. We've helped those startups do about 60 deals in the local market. And we've had many successes in the companies, and those companies have raised almost $100 million post our program. So really kind of a newer program, a new accelerator program in real estate technology right here in the state of Connecticut. I wanted to spend a minute just talking about not only Upward Labs, which is this accelerator program, but we're part of the broader innovation movement here in Connecticut and in Hartford. So right in downtown Hartford, we have a co-working space, a 30,000 square foot co-working space and event space called Upward Hartford, where our entrepreneurs can work and have an opportunity to grow their business. We have a living space as well, something which is called Upward Living, which is a co-living space for technologists, for entrepreneurs, for corporate innovators, really targeted at that demographic. And then Upward Labs, which is the program that I'm the director of, which is the startup accelerator I just mentioned. I wanted to go through some of our partners. We do have a great partner list and folks who have participated as part of the program. So Shelbourne Global, who is the largest commercial landlord in downtown Hartford. Lexington Partners, many of you might know Marty Kenny, very active. They own about 4,000 multifamily units throughout Connecticut and increasingly across the Northeast. UBS Real Estate is a partner, Stanley Black & Decker Carrier, alongside a lot of the insurance companies. So, you know, we've done a halfway decent job of building a community of commercial real estate, multifamily real estate, large corporations that are supporting our community and our ecosystem. I will say that we would love to add in more home builders into this list, and particularly single family homes. We're very heavy in multifamily from a concentration perspective, but certainly would love to add in more home builders onto our list. Just 1 or 2 minutes as well on a new initiative that we have at Upward Labs, and this is kind of the kickoff to the discussion that we're about to have. So we just launched something which is called a Net Zero Lab. Many of you will know that the real estate industry accounts for 40% of greenhouse gases, so very, very significant contributor. And there are many regions, jurisdictions, which are starting to pass increasingly stringent laws and regulations, which are capping carbon emissions and capping, in various times. So some are capping it by 2030, some are capping it by 2035, but we are undoubtedly on a trend here in the near term towards decarbonizing the real estate industry. And so our lab is going to pair innovative startups in net zero alongside partners for them to really explore technologies, test technologies, pilot technologies, and come up with solutions to a lot of the industry's pressing problems. And for many of you who might be familiar with this area will know that we're basically in the first inning of what is going to be a 9-inning game for sure over the next 30 years. I mean, we certainly need new solutions and new approaches to old challenges in order to solve the decarbonization challenges for the real estate industry. And then last, from my perspective, if there are folks that are out there who are interested in getting involved in our net zero lab, certainly reach out to me. I've got my email address here, greg@moveupward.city. We have multiple levels of partners. It's very easy to get involved in what we do. It's unpaid for our partners. And so it's you volunteer time as opposed to money, and would love to explore and have an opportunity to work with some of you who are interested in getting involved. So that's it for Upward Labs. Hopefully that gave everyone a good overview of what we do, how we do it. Feel free to reach out to me, connect with me on LinkedIn, send me an email if you want to get in touch. And with that, I think I'll stop sharing and turn it over to Daniel Burton, who is the founder and the CEO of one of the companies that came through our program in our 4th cohort and has a really, really great technology solution right in the sweet spot for net zero homes and multifamily communities. And he's someone who is bringing technology over from the UK over into the United States. That really is the type of thing that's going to move the industry forward. So, happy to have him present a little bit more about his business and technology for the balance of the program. All right. Hey, Daniel, I think you have it on mute. If you can.
Maybe muted now.
Yeah.
Hi guys, nice to meet you all. Let me just bring up this presentation for you. Now, just a quick one just before I start, because I know when I use this on my Mac, it never seems to click through. But does that click through okay?
Yeah. Yep.
Perfect.
Yeah, it's clicking through great.
No problem at all. Nice to meet you all. My name is Daniel Burton, as Greg said. But Wondrwall are a European technology company. We were voted last year as the best prop tech company in Europe, and part of Wondrwall is the goal of getting homes down to net zero. Back in 2014, we were actually founded as a home automation business, and that was the core of our platform. And what we developed was a light switch. And what this light switch has, it has 13 sensors built within a light switch. So if you can imagine in one of your buildings in your home, taking your light switches off the wall, putting a Wondrwall light switch on the wall, what you do on average is put about 130 sensors within a home. And what that's actually doing is actually learning about how people live and behave within their home and how that performs. So understand everything from heating patterns, sleeping patterns, occupancy patterns. We send that data up into the cloud, and we have machine learning and predictive modeling that's constantly learning from that data. We have about 20,000 data points a day on each individual home. And what that's given us the ability to do is actually control the home intelligently. So we started off controlling heating and lighting because it was the most obvious thing to save consumers money. So if you lived in a Wondrwall home and you go to work at, say, 7 o'clock, the home knows what time you go to work. So it would turn the heating off at 6:45 because it knows it would state your ideal temperature before you walk out the door. If you walk out the door and you've left any lights on, the home knows you've gone to work, so it turns all the lights off for you and also puts your alarm on. What also it would do is if you go for a few drinks after work, the home knows you're not coming home. So it's not going to turn the heating on. It will work out when you are coming home and only turn the heating on when you are coming home. So fundamentally, what we're trying to do is reduce energy consumption right from the beginning. We just don't want to waste any energy in the home. On top of that, we have quite an advanced security system. We have 2 motion sensors built into every light switch. So on average, we'll have maybe 20 motion sensors all around the home, which is a really sensory-based alarm system. Most alarm systems may have like 3 or 4 PARs dotted around the home. But some of the things we also wanted to do is we wanted to catch burglars on the outside of the house before they got in. Because if you can imagine, a burglar would smash a window, get into a home, he'd only trigger a sensor once he's in the home. But once he's in the home, he's going to do whatever he wants to do anyway. So what we did is we got the light switches to listen for 2 sounds, and one of them is a window smashing. So if a window smashes, the light switch will pick up on that sound and starts flashing all the internal and external lights, sounds the burglar alarm, and also records what's actually gone and sent it to your phone. So if you can imagine, a burglar window goes in, lights go off, alarm goes off, he's going to run off. On top of that, if you're away from home, the home will turn on certain lights to look like it's occupied. It just gives that illusion of occupancy. We also have some safety features. So we have a key fob which arms and disarms the alarm system. It also acts as a panic button. So if someone's vulnerable at home, and they can press the panic button and it'll alert everybody in your address book. There was also some research done where young children don't wake up to the sound of a smoke alarm because the frequency it emits. So what we did is we got the light switch to listen for the sound of a smoke alarm. And if a smoke alarm goes off, it will pick up on the sound of the smoke alarm and starts flashing all the internal lights to wake everybody up. We're also a technology partner of Amazon's. We're the first people in Europe to put Amazon's voice technology into our own hardware. So every light switch within the home is an Amazon Alexa device, which allows you to control the whole home just by talking to a light switch. We also got a call from Sonos probably about 4 years ago, and they said, look, we love what you're doing over in Europe. Can you integrate Sonos into the Wondrwall system? So I think there's only 10 partners globally fully integrated with Sonos. So you can talk to your light switch and say, play Michael Jackson out of my living room speaker, it'd be fully integrated. So that's what we started off as a business, launching that technology into the market in 2018. What we realized quite quickly is decarbonisation and climate change was becoming a bigger agenda. In Europe, we can't use gas in our residential buildings past 2025. So we have to look for a different way of how to heat our homes. So we developed some technology. We looked at all different types of heating technology. We looked at heat pumps, ground source heat pumps. We weren't happy about the way that they perform, how you maintain them, and how they're heating the home constantly. So we developed 2 different types of heating technology: electric underfloor heating and infrared heating panels. But it was the way that we controlled the heating within the home made it a lot more intelligent. So if you can imagine your home, you turn your heating on and it heats up your whole house. Well, the problem with that is that we're wasting a hell of a lot of energy heating up rooms that were not occupied. So what we decided to do is use the data within the home to learn about how people occupy their home. And what we found quite quickly is that people have certain patterns around what rooms they spend time in. So what we implemented was a technology that learns about where you're going to spend your time and only heats the rooms to your ideal temperature in the rooms that you're going to spend your time. So you may spend between 6 and 10 in a living room. Well, we'll make sure that's at your ideal temperature, but we're not going to heat the rest of the home. We'll have a set point so it doesn't drop below a certain temperature. And what we can do is we can reduce energy consumption by 50% by heating homes based on occupancy rather than heating up the whole home. Then we developed a hot water cylinder. We developed a hot water cylinder which learns about how much water you're going to use within the home. And instead of heating up 200 liters of water, the cylinder learns about the flow of water. And if you only have a shower and use 30 liters of water, the cylinder will only heat up the amount of water that's required. So what we're doing is just being really intelligent of how we provide heating and hot water into a home. The next step of our evolution was to create net zero homes. We believe every home should be sustainable, create its own energy, store its own energy, and use its own energy. So we developed some battery technology, 6.5 kilowatt residential battery, inverter, and then we put solar on the roof. So what you have here is you have a home that generates energy, stores energy, but where Wondrwall completely different to any other solar and battery company globally is having the intelligence within the home to control these energy assets. So what this home will do this evening, it will download the weather data for tomorrow. It will calculate how much energy the solar is going to generate. And then it's going to make a calculation of what is going to be the demand for that next day for that home. If it's a summer's day, I'll generate enough energy to power my home. If it's a winter's day and I'm not going to generate enough solar, what we do is we have a direct link into the energy companies, which gives us the ability to buy energy every 30 minutes that next day. And that cost can range from 2 cents a kilowatt to 25 cents a kilowatt. So what we're going to do is we're going to work out when's the most optimum time to take energy off the grid. So normally at 2 o'clock in the morning, energy drops to its lowest point when no one's using energy. We'll charge up our battery and charge up our hot water. And then when the consumer gets home, they're either going to use free energy from the solar or very cheap energy off the grid to power that home. If you're away from home, what the home will also do is work out when's the most optimum time to sell that energy back to the grid. So it'll wait till peak demand and actually sell that energy back to the grid and give you a revenue stream. We also have an EV charger, which plugs into the system, and it also uses the same type of technology. You plug your car and you'll say to your home, I want my vehicle ready for 7 o'clock tomorrow. What the home will do then is calculate when's the most optimum time to charge that vehicle. So it's not going to charge it at peak time. It's going to wait till probably 10 o'clock in the evening when energy prices start to drop. And then it's going to charge up that vehicle between 10 and 6 in the morning before energy starts to rise in the afternoon. So that just gives you a brief overview from a technology perspective of what we do as a home. This is in pounds, but this gives you a bit of an understanding of the reduction on energy. On average, we're saving about 90% of the energy bill. So if you look at what we do from a gas perspective, this is in pounds, but in the UK, to heat your home for a standard 3-bedroom home is around £730, and it emits about 1,473 kilograms of CO2. A heat pump is more expensive because it's electric. We're saying about £854, but it's still emitting a hell of a lot of CO2, 1,237 kilograms. On average, a Wondrwall solution, the energy cost would be £223 and only emits 668 kilograms of energy of CO2. So you can see a big reduction on energy costs. These are a couple of case studies. These are homes that are actually running to a net zero standard. So they're generating more energy than they actually use. But you can see that we built the solar into the roof. We have a battery, an inverter under the stairs, and all the controls that are controlling all aspects of the home. We also do quite large buildings. So family, what you class as family. These are build to rent schemes, what we class in the UK. But what we have and what we do for developers is that we digitalize this asset. This building has got 144 apartments on it, but this building has 16,000 sensors built within this building. What we do from a global view is that an operator can log into this building and understand exactly how it's performing. So it understands everything from how the building heats up to it cools down, the energy demand, also how much energy this building is saving. Because when you walk out the door, it's turning the heating off, it's turning the lights off, and then it can calculate how much energy for that day it's saved to save that building. So you can see it from an overview of what's going on. We also have solar built into this roof, and what we do is we distribute the energy that's generated from the solar between each apartment within that building. This is just an example of how the technology works from a day-to-day basis. So a day in the life of Wondrwall is that you've got energy demand in the home, and then obviously you're generating solar, which is being stored within the battery. And then at peak times, what's actually happening here is it's taking the energy out of the battery to offset that demand. So these are some good examples. So obviously from a developer's perspective, what you are developing is you're building homes that are completely different to what's out there on the market. You're standing out from the crowd. You're building sustainable buildings. And also you're reducing the cost of an energy bill by about 90% for your customers. Customers are obviously going to be wanting to see greener, more intelligent homes, and that's what we provide. But it's very simple and easy to use. If, for example, if we're looking at a 4-bedroom home, an example for a home energy management system, heating, hot water, battery, solar, and an EV charger, on average, that costs around $15,000. But what you're getting for that is you're getting a very efficient, intelligent home. So that just gives you a brief overview of obviously what we do as a company. Thank you.
Oh, great presentation. That's fast and furious information, and I know there's some questions out there. So, Jim, do you have some questions in your chat room already for Daniel?
Not at the moment. So, Bill, if you'd like to.
Okay, so I mean, I actually have. I was thinking of something as you were talking. So, the first thing that comes to my mind is the application of solar on homes that do not have the most optimum exposure. I mean, everybody knows you got to face, at least in the northern hemisphere, you got to face south. I've seen some of the solar companies around here take liberties with that, with east and west. You certainly can't face north. So what do you offer as solutions for homes that are not situated in the most optimum location?
Solar over the years is becoming a lot more efficient. At the end of the day, when we started out, we were probably our panels were probably 200 kilowatt. They're now at probably 450 kilowatt panels. But the whole part about actually pointing south, actually even east and west, you're going to get a lot of generation for your actual solar. So at the end of the day, you will still generate a hell of a lot of energy if you're facing east and west. North obviously is never ideal, but at the end of the day, if you're facing north, you may be able to get panels on the front which would facing south. So there's normally always going to be an aspect of the roof that you can actually put solar on. If you can't put solar on, at the end of the day, what we will do is we'll have a battery in there to offset the costs. So in essence, what the battery would do would actually buy energy at very cheap rates, 2 cents a kilowatt, store it, and rather than paying 20 cents a kilowatt, you're actually offsetting that cost, if you will. So there is a couple of different options, but solar, the majority of the time, even in rainy UK, we can still get solar on the roof and generate energy.
Okay, so just to follow up to that, you said something interesting that I hadn't figured out, because one of my kind of bugaboos about solar was really the efficiency of the panels. So, are you saying in the standard size panel that a solar panel can now deliver up to 450 watts?
450 watts is the new panels that we're using now, yeah, which is completely different. The problem with solar is that every year, last year on average, we were doing 370 watt. This year we were doing 450 watt. So they are always increasing in what they're actually performing out. So yeah, completely different. The technology is obviously great technology because it's been around for a long while, but actually every year it's getting more efficient, more efficient, more efficient.
Interesting. Okay.
Bill, we do have a couple questions in the chat. I can rattle them off for you if you like.
Sure. Yeah. Why don't you go ahead?
So Mark Nizzolo asks, can you itemize your costs for the 15,000?
Yeah, so on average, the cost, so the home automation system, which would include 10 light switches, you'll have, depending what type of heating controls, we have different types of way to control different types of heating. But you'll have your home automation, your alarm system, you'll have a keypad as a system, as a home automation system. Then you'll have 12 infrared heating panels, a hot water cylinder, so a 200 litre cylinder. Then you'll have all the in-roof mounting. So all the solar that we put on roofs, we normally put it in roof. So flush to the roof, in-roof mounting. And then you'll have 4 kilowatt of solar, which on average is anywhere between 8 and 10 panels, depending on what size panels you're using. And then an EV charger, which is a 7 kilowatt EV charger. So that is a list of the components, if you will.
So Chris Nelson appears to have a couple of questions for you. The first being, are you currently working on homes in Connecticut, and if so, are any completed?
We are just, we're working on our first projects at the moment. So they're not actually completed at the moment, but we are working on some projects in New York. So they are probably the closest that we've got that we're working on.
Chris's second question is, why are radiant heat panels lower cost to use than heat pumps?
It's the way that we control them. If you can imagine that if you put a heat pump into a home, what you're doing is the heat pump is constantly running. Now, what we have is the intelligence to control the heating within the home intelligently. So we're not taking the amount of demand that a heat pump would require. So that's how we reduce the cost of actually how we control the heating. Rather than the heating being on constantly, We can heat up the home. If you're not home, we're not going to turn the heating on. We work out when you are coming home. So there's a lot of different ways that our intelligence that controls the heating within the home to reduce the demand from the beginning. And that's how we can make the heating technology lower cost than actually a heat pump.
So Pete Pissarro asks, how do you handle air conditioning, I guess is what he's trying to say.
Yeah, funny enough, we're just integrating the same type of technology to control all different types of air conditioning units. So we are working on that at the moment. We're probably going to be finishing that probably in the next 6 to 8 weeks. We're just launching the technology in the Middle East, and part of that was to actually integrate air conditioning units, so we can control the top 15 brands of air conditioning devices. And obviously we can use that same type of philosophy around cooling rooms based on occupancy, rather than turning every air conditioner in the home, but it's intelligent. So it'll work out when you are going into rooms, when you're not going into rooms, when you're not using them, and controlling it intelligently.
It looks like George LaCava would like to know where your panels are manufactured.
Which panels do you mean? Do you mean solar panels, or do we mean infrared panels? The solar panels, to be honest, we use normally a tier 1 Chinese supplier, like a Trina Solar, people like that. So we buy from a tier 1 manufacturer. Our infrared panels are made by we design them, and they're made actually in Europe at the moment, in Poland, by a company called Flextronics, which is an American company.
Good. Bill, those are all the questions I see at the moment. Oh, looks like you have another one. Joanne Carroll asks, have you approached utilities in Connecticut with your management system, and are you using solar shingles?
No, we haven't approached any utilities, but we are. That is literally next on our jobs to do, because one of the most important parts for us, and if I can give you maybe a bit of an overview of obviously what we're doing as a business from a utilities perspective, is that what we do is we aggregate. What we do is we digitalize assets, but what we do is we create community energy. And what we mean by that is, what we have is that every home is connected, and it gives you the ability to share energy between houses. So every house can talk to each other, communicate with each other. If you're not home, you can share that energy within that grid. So that's what we've developed in Europe, is actually a digital energy business, which sits on top of the grid and connects all these assets together. And all these assets share energy. And that's what we class as a digital energy business. But that's what we will be doing in the US, very similar to what we've done in Europe. And I'm quite happy, if anybody wants to see a presentation of that digital energy side, I'm quite happy to share that with the guys later, and they can pass it on.
Yeah, I would mention one thing too, Danny, just as we're talking about the utilities in Connecticut. So we have had conversations at the Upward Labs level with Eversource, and Eversource is very interested in the Wondrwall technology. Eversource has, for those of you who might not be familiar, they have a 200-person energy efficiency group that pilots and tests new technologies, that has funds available for piloting new technologies. And so if there are home builders that are in the audience who might be willing to partner with Wondrwall and partner with Eversource on use cases and case studies, I'm sure they would be very interested in doing that. There's also money available from, I had a conversation this week with the Deputy Commissioner of Department of Energy. There's substantial money available from the Department of Energy for the testing of new technology as well. So for those who are interested in exploring the solution, there are a few different avenues from that perspective.
You know, I'd like to just follow up on that and ask a question. Has Eversource mentioned what would make a sufficient case study? What kind of numbers? How many houses? How many multifamily would they like to see involved in a case study?
Yeah, I think it's all still in process, Jim. To that extent, obviously their pilots are typically on the smaller side, so it's smaller scale pilots. So, but they haven't mentioned an exact number of homes or an exact number of multifamily units. That being said, this system is probably 3 to 5 years ahead of, or if not longer, in front of many of the solutions that they're basically looking at. And so there was heavy interest from them in finding a good pilot partner. And for them, it was partnering with the important thing for them is partnering with the right home builder in order to get the test study and the pilot out there.
So we have the questions rolling in here. So Mark Nizzolo asks, how do you wire your switches and what controls?
So yeah, they're just wired into a standard light switch. So at the end of the day, you can wire in a live and a neutral, and then you have your light. So it just fits into it as you would normally wire a standard light switch.
And Chris has an additional question. Do most adopters use the complete system, or are some using certain parts of the system?
Yeah, it's completely modularized, so you don't have to take every part. You can take different parts. And for instance, we've been asked by the UK government if we could integrate a heat pump into the Wondrwall system to make it a lot more intelligent. So we have done. So we're all about collaboration. We're all about finding a solution that fits all. So at the end of the day, what we can do is we can take any device, integrate it into the Wondrwall system, and just give it that extra control that we have.
So it looks like Jerry Effern's ready to talk turkey with you. He writes, for a 2,500 square foot, 2-story luxury home, slab on grade, would you be able to supply 40 homes starting in 90 days? I'm in the Eversource region.
We shouldn't have a problem with that. We'll probably need to sit down, but we won't have an issue with supply. At the end of the day, the supply is available, not a problem at all. Just a case of doing some designs and doing some work for you. But at the end of the day, what we normally do is if you had some designs of these houses, we can take them away and do a full design for you and a full proposal. Happy to do that. Happy to take that offline. Not a problem at all.
We'll be happy to connect you to later on. George LaCaba asks, in climates such as ours, where you can't completely shut off the heat, how does that affect efficiency?
Yeah, so we don't shut off heat. If you can imagine, what we're doing is we can actually pulse heat. What we're trying to do is we're not shutting off heat. What you can do is you can set a set point so your home doesn't drop below a certain temperature. So at the end of the day, what you can say is, okay, I don't want this home to drop below 17 degrees. So actually, if a room is actually dropping below that, the temperature, the devices turn on and heat up their rooms. It's not like we are leaving a house to go cold. We all know that if you leave a house to go cold, it takes a lot more energy to heat it back up. So in essence, what we can do is we can pulse that to make sure it stays at a certain level.
So Terrence Beatty appears to have a liability question for you. What risks are there, if any, for a homeowner? Can they be tied to legal action in the digital grid?
Sorry, I don't quite understand the full question. At the end of the day, when we talk about digital grids, that is what we normally do when we create a digital grid, is that we do that for if there is anybody out there that do affordable homes. So what we do, what we class as affordable homes, is that if someone owns 10,000 homes, part of our finance packages, we can say, okay, we'll retrofit these 10,000 homes. We'll pay $150 million up front to retrofit these homes. Then what we do is actually we take them homes and then we create a digital grid of them 10,000 homes, where every building is connected, if you will. So there's not really that legislation does. There is legislation in Europe where we can't keep customers into a certain energy company for a certain amount of time. But what we do is we can get around that by actually, from an asset perspective, we can charge the asset over a period of time. So I'm not understanding the full question, but I can take it offline and have a question later.
Sure. So, Bill, there aren't any additional questions in the chat.
So I actually have a couple of questions myself. So, and they're totally unrelated. So I'm fascinated by basically the data inputs and that allow you to increase efficiency. I totally get that, and that's very admirable. But my question has to do now with the whole reduction of carbon footprint, which is also something we're trying to achieve here. So in an area of the world like Connecticut, where we are, where much of our electricity is being generated by non-renewables, by natural gas or oil still. So if I change over my house so that it's all electrically powered, okay, realizing that you're giving me some renewables by virtue of your solar, but the electricity that I'm buying still is being produced by some kind of generation that has itself a carbon footprint. Is that correct?
It is, but if you can think of the carbon footprint, normally the big carbon footprint of electricity is normally at peak demand. So normally what the grid will do is when it gets to 4 p.m. when everybody comes home, they'll turn on the power to turn on coal or oil or nuclear, etc. So that in essence is when the carbon intensity of electricity is at its peak. What Wondrwall does is take energy off the grid when it's less carbon. So at 2 o'clock in the morning, when it's standard electricity, that's when we take electricity off the grid to charge the batteries within the home. And then what we do is we keep that energy and we power the home based on that energy and not use the very carbon intensive energy between 4 and 7. So that's how the big carbon reduction is achieved.
Okay, so I guess I'd run a further discussion with you offline because, so, I mean, are you telling me that if there's a diesel generator generating electricity, even though the demand is lower at say 2 o'clock in the morning, which makes sense to me, perfect sense to me, but that generator is still running, correct? It's still running.
Well, not normally, because what they do is they only use these generators is when they actually need demand. When the demand is there, energy flows like water. So you're always going to have energy within a grid. So what you're going to do is what actually happens, if you can imagine when people turn on the taps, more water flows. So in essence, what these generators are only turned on normally when there's demand. When there's no demand, okay, the electricity is not as carbon intensive.
Okay, then it makes sense to me. Okay, so I have a second question. It's totally unrelated to that. So yeah, but earlier we had a discussion about it's a modularized system. You can use all of it or part of it or whatnot. And it kind of makes sense to me that your switching is easy to set up because we're using the conventional wiring that we're probably putting in our houses anyway. But it strikes me that when you get into your other specific products, like your infrared heating, like your hot water heating, whatnot, it begs the question of, do we need special installers for this, mechanical contractors, or how are we going to accomplish that?
To be honest, all the components are standard components. So for instance, the cylinder is a standard cylinder, from any cylinder manufacturer. It's got an input and an output. What we have is we just have technology that sits on top. So all the cylinder is exactly the same as you would normally sit. It's just we've got technology on top of it. And the infrared panels are, if you can imagine, maybe would you like to see a video of actually what a home looks like? Would that be quite interesting for you?
Sure.
It's only a very short video, but let me just bring up a video and I can talk you through the process, if you will. Just 1 second for me.
So how short is it though?
1 minute, 30 seconds. Is that okay?
Have at it. That would be appreciated. Sure.
No problem. 1 second. It just gives everybody an understanding of actually what it looks like when it all comes together. So, can you see this okay? Or do I need to share my screen?
I think you'll need to share.
Okay, 1 second for me. Can you see that okay?
Yes.
Perfect. Right, this is an example.
Hello, I'm Jake. I'm one of the site managers here in Redrow, Yorkshire. Here we're at Langley Grange development in Sisset, Huddersfield. Here we have built a low carbon home featuring Wondrwall's energy reduction technology. This house has got no gas boiler and is instead powered by solar energy and electricity. If you come with me, I'll give you a quick tour around and explain a bit more. Installing Wondrwall smart home technology gives the home the intelligence to control itself, saving time, money, and the environment, and changing the way we use energy. On the roof of the house, there are 10 solar PV panels. These generate renewable solar energy for use in the house, or they can be used to replenish the battery or sell back to the grid. Here in the garage, we have Wondrwall's hybrid inverter and battery. The inverter takes the power generated from the solar panels and converts it into usable energy for the home. Any energy not used within the house is stored in the battery, so even when the sun's not shining, the home can continue to run on clean energy. We'll be moving away from fitting fossil fuel boilers in the future. In this home, we are trialling infrared heat panels. There are 13 heat panels throughout, fitted into the ceiling to provide heat for each room. We think these heat panels look really good, as well as giving more space to each room, as there's no need for radiators on the walls. To make this a smart home, we have installed 16 intelligent light switches. These switches contain 13 sensors. These sensors monitor how you live and learn your patterns. This means the heating and lighting can be controlled most efficiently. As well as the sensors, these light switches also contain Alexa's voice assistant. For example, Alexa, what's the weather like today?
Currently, in Skissett, England, it's 11 degrees Celsius with mostly cloudy skies.
This is the smart hot water cylinder. It produces hot water for use throughout the home. Using Wondrwall's home automation system, it learns your patterns to only produce what you need when you need it.
So that's just a brief example, but if I can talk you through the installation of this, because what actually happens is that we will actually speed up your build programs by about 3 weeks. Because what you don't have to do is that you're not putting 90% of the piping through like you would normally put radiators, etc. on. All you're doing is doing a partial, adding an extra layer, an extra cabling for your infrared panels on your ceiling downstairs, and an extra electrical cable for your ceiling upstairs. So you're taking out all of that plumbing cost, if you will, but also you're reducing the risks on water damage, flood damage, because in essence, you're reducing all that piping, if you will. So a very simple system to install, and any electrician or any plumber can install it.
Okay, thank you. Jim, did I see new questions coming into the chat area?
It looks like Mark is asking it appears to be the same question that Pete asked earlier about how you cool the homes. So I don't know if there's any additional information you have on that, or.
Yeah, no. So we've integrated the ability to control all the major air conditioning devices within a home. So that would be launched in the next probably next couple of months.
You know, I wouldn't mind following up with regard to retrofitting. So obviously you're talking to a bunch of developers and home builders. Some of them also are remodelers. And how does pricing differ for those who are retrofitting versus new construction?
There's obviously the only extra cost really is when you're retrofitting is the cost. So if I can talk you through what a process would be, normally if we're doing a retrofit, we'd do a survey, then we'll do a design, and then the first process of that is removing the gas boiler. So taking the gas boiler out, we'll cap the radiators, remove the gas radiators out of the house, do a partial rewire where we're going to rewire and install the infrared panels. We're going to change the light switches within the home, and then we're going to fit solar and battery and an EV charger to that home. So very simple. We do complete retrofits in about a day and a half. That's probably how long it takes us to do a complete retrofit of a home.
Interesting. Yeah. Okay. Any other questions there, Jim, in the chat area?
I don't see any at the moment.
So yeah, you may have spoken to this earlier, Dan. I apologize if I did not hear it all. But so you're talking to an audience of multifamily and single-family developers in a relatively small state. But the ones that were on the call and others in our association are, I would like to think are at the kind of on the leading edge of technology and whatnot. So that kind of begs the question of how can any of us get involved with your company kind of on an experimental basis to kind of feature your products in our homes where we can kind of distinguish ourselves and also advance your product? What would be the steps we would take to do that?
At the end of the day, we're opening up. We're really open to working with anybody. Really, at the end of the day, our focus is obviously building momentum within the US. So getting some pilots up and running, getting people understanding how this kit gets installed is exactly what we're looking to do. So anybody happy to reach out. I'm sure you can share my email, and I can share a couple of brochures as well with everybody. So if anybody wants to reach out, happy to have a conversation.
Excellent. Very good. Okay. So Jim, can you, do you have anything else we want to field for the benefit of the meeting? Any other questions or comments from our audience?
It doesn't appear to be at the moment any additional questions. Looks like we're
Right.
good.
Okay. All right. Well, listen, I appreciate the efficiency of your presentation as well as your products, Daniel. You did a very good job of that. And Greg, also thank you for giving us some idea about what you guys do downtown Hartford. Daniel, I'd like to invite you at any time, if you're in the States, to please give us a personal presentation to our group. I'm sure we could probably get more people in the room for that. And I think that if I know the people who are on the call, I'm sure they're going to have some interest in following up to see how they could become involved in using all or part of your products. So with that, I'm going to thank everybody for being on the call, especially our presenters and Jim, and wish you a good rest of the day. I don't think we have our seminar set up for next month, but Jim and I will get that out to you. And I thank everybody for attending. Have a good day.